Welcome to Spring LIB.
We're asked to find at least 3 different sequences generated by a simple formula or rule whose first 3 entries are 3, 5, and 7. So our first observation is just that these are the first odd numbers, excluding 1. So what we can write is an is 2n plus 1, because remember that 2n is always an even number, and if you add 1, you get an odd number. And with this formula, in fact, we see that a1 is twice 1 plus 1, which is 3. a2 is twice 2 plus 1, which is 5. And a3 is twice 3 plus 1, which is 7. And we found our first sequence. Then we can also observe that every element of the sequence is the previous one plus 2. So in fact, 5 is 3 plus 2, 7 is 5 plus 2, and so forth. So we can write an plus 1, so the next element of the sequence is the previous one plus 2. And of course, we need to begin with something. So let's put a1 equal to 3. So a1 is 3 by definition. a2 is the previous one, so a1 plus 2, which is 3 plus 2. In fact, it's 5. And then a3 is the second entry, a2 plus 2, which is 5 plus 2, which is 7. Okay, to find our third sequence, we can think of the prime numbers. So remember that the prime numbers are positive integers which are only divisible by 1 and themselves. So for instance, 4 is not prime because 4 is divisible by 1, 2, and 4. Instead, 5 is prime because it's only divisible by 1 and 5. And this is a well-known sequence. Its first entries are 2, 3, 5, 7, 11, 13, 17, 19, and so forth. And we see that 3, 5, 7 appears there, except that we have a 2 in front. But also 2 is the only even prime number because every other even number is divisible by 2 and therefore cannot be prime. So if we define our sequence an to be the nth odd prime number, we're in fact keeping the 2, and this sequence is the sequence 3, 5, 7, 11, 13, 17, and so forth. And therefore we found our third sequence.